Hello friends, welcome back to my YouTube channel. Today I'll be discussing a numerical based on flash distillation. In my earlier video I have discussed the concept of flash distillation. I hope you have seen that video. For those who have not yet seen the video, I'm giving a link to that video in the description section. So this is my discussion on distillation, and this is part 10 of that discussion. So here I'll be discussing flash distillation, and now I will be talking about I'm continuing my discussion on flash distillation, and now based on the concept that I discussed in my previous video, I'll be discussing one numerical. Okay, so let us start the discussion. First, let me show you what is the numerical statement. The numerical statement goes like this: a liquid solution containing 50 mole percent N-heptane and 50 mole percent N-octane at 30 degrees Celsius is to be continuously flashed, vaporized at 1 standard atmosphere pressure to vaporize 60 mole percent of the feed solution. What will be the composition of the resulting vapor and the liquid? And the boiling point of N-heptane is 98.4 degrees Celsius, and that of N-octane is 125.6 degrees Celsius. The relative volatility for the system is 2.16. Okay. Now we will learn how to solve numericals like this. I have discussed two methods. One, we will learn how to solve it graphically, and then we will also learn how to solve it analytically. So first let us note down what are the given things in this numerical statement. The feed solution in this case is solution of N-heptane, let us denote it as A, and N-octane, let us denote it as B. Boiling points for both these components, they are given. Boiling point of N-heptane is 98.4 degrees Celsius, and boiling point of N-octane is 125.6 degrees Celsius. So from the boiling points we can conclude that N-heptane is the more volatile component. So we will be talking in terms of N-heptane, more volatile component. Then the feed is containing 50 mole percent of N-heptane. There is N-heptane in that feed, in the feed solution, which means that XF is given to us, mole fraction of more volatile component in the feed, it is given to us. It is 0.5. So I have converted mole percent into mole fraction by simply dividing with 100. So that's why I get XF is equal to 0.5. Okay, then they have also told us that the process is the feed solution is to be continuously flash distilled. It is to be continuously flash vaporized. Flash vaporized is nothing but flash distillation, because the other name for flash distillation is flash vaporization. Then how it is to be carried out? It is to be carried out in such a way that 60% of the feed solution gets vaporized. So that means the fraction of the original feed that gets vaporized, it is known to us. So again the percentage is converted to fraction by dividing with 100. Therefore F is equal to 0.6. So small f that we need in our calculation, it is given to us, it is 0.6. Then temperature and pressure, they are given. Temperature is 30 degrees Celsius and pressure is 1 standard atmosphere. Further, is any other parameter given in the statement? The answer is yes, because we have the relative volatility. Relative volatility is given to us, it is 2.16. So the relative volatility is given. We are going to denote that by alpha AB, that is 2.16, that is given to us. Okay. And what is the objective? The objective is to get composition of the resulting liquid and vapor phases. That means if you want to show it by a simple schematic diagram, you can show it like this. You have this operation. Okay. Then feed is passed. I'm just showing you the schematic. So feed solution is passed and it will be flash vaporized in this vessel. Then vapor, after due to flash vaporization, the feed solution will be partially vaporized. That is, it will be a two-phase mixture. Okay, then vapor and liquid, they will be allowed to come in equilibrium with each other, and after an equilibrium is achieved, vapors are removed from the top, which has Y as mole fraction of more volatile component in it. Y in this case is mole fraction of more volatile component, and more volatile component is N-heptane. Then the liquid is also removed, and liquid has X as the mole fraction of more volatile component in it, and our objective is to get these values. Our objective is to get X and Y. Okay, so with all the given data, we are supposed to get the value of Y and value of X. Okay, so as I said earlier, I'll be discussing two methods by which you can get. First is you can get it by solving it graphically by plotting the distribution diagram, then by plotting the operating line for flash distillation, and then noting down the values of X and Y. Okay. I will also discuss how you can solve it analytically without drawing any graph. So let's understand. So X and Y we need to find out. The objective is to get the values of X and Y. Okay. So now let us start the solution. First, let me just note down for a graphical solution for finding the required answers by plotting graph. Let me first tell you what are the steps involved in it. So first is we need to generate vapor liquid equilibrium data, that is VLE data. Vapor liquid XY data is not given to you. XY data is not given to us, that is VLE data is not given to us. We need to generate it, and we are going to generate it by using relative volatility, which is given to us. Then after generating the data, we are going to plot that data. By plotting the VLE data, we are going to get the distribution diagram. Then once you plot the distribution diagram, on that distribution diagram we are going to plot the operating line, and the point where operating line intersects the equilibrium curve, the coordinates of those points are going to give us the values of X and Y. Let me just tell you. So after generating XY data, we are going to plot the data. Okay. So how are you going to plot it? On y-axis, you'll be plotting Y, mole fraction of N-heptane in the vapor phase, various values, and X, mole fraction of N-heptane in the liquid solution. So these are equilibrium values. So you'll be getting a curve like this. This is the distribution curve. Okay. Then we will be plotting, if you please watch my earlier video, there I have explained how to plot the operating line for flash distillation. Okay. So it is plotted like this. So you have the diagonal line, This is the diagonal line. Then you just have to locate a point on the diagonal line which has coordinates of xf, xf. xf is given to us. Okay. So once you get this point, the y coordinate for this point will again be xf, because that is the point is lying on the diagonal line, and then we will be plotting the operating line, and we are interested to know the coordinates of this point. Okay. So this will give us x, that is mole fraction of more volatile component in the resulting liquid, and this point will give us y, mole fraction of more volatile component in the vapor phase. So ultimately we are going to report as values. Okay. So basically this 4 steps gives us the desired answer graphically by using graph. Okay. So now let us follow. We need to follow these 4 steps. Let us start with the first step. First step is generation of the VLE data. How are you going to generate it? In my earlier videos, I have discussed numericals where I have told you how to generate the equilibrium VLE data. So for that we need to use this equation: y is equal to alpha AB x divided by 1 plus alpha AB minus 1 into x. So this equation can be used in case of when you have a ideal system, an n heptane and n octane, they can be assumed to be behaving ideally, and you can use this equation. So what is the approach? We are going to select values of x that lies between 0 and 1. Okay. And then the corresponding values of y are calculated by using this equation. So various values. Why you have the range between 0 and 1? Because the minimum value for x can be 0 and maximum value can be 1. X being mole fraction, it cannot be more than 1. That's why we need to select various values lying between 0 and 1. Okay, so let us now move ahead. Again, continuing with the same step number 1, generation of the VLE data. The equation to be used is y is equal to alpha AB x divided by 1 plus alpha AB minus 1 into x. The values of x selected are, we are going to select these values 0, 0.1, 0.2, 0.3, 0.4 up to 1. For x is equal to 0, let us know how to get y. So alpha AB, it is given to us, it is 2.16. Now for x is equal to 0, y will be 2.16 into 0. So I'm replacing x with 0 now, divided by 1 plus 2.16 minus 1 into 0. So that gives 0 upon 1 plus 0, that is 0 upon 1, which is 1. Now for 0.1, x is equal to 0.1, again you are going to get y in the same way. Y is equal to 2.16 into 0.1 divided by 1 plus 2.16 minus 1 into 0.1, which after simplification, that is 0.216 divided by 1 plus 1.16 into 0.1, that is 0.216 divided by 1.116, which gives us y as 0.19. Okay. Similarly, values of y are calculated for remaining values of x. So I have shown it for first two values, x is equal to 0 and x is equal to 0.1. Next value of x will be 0.2, 0.3, then 0.4, so on and so forth till x is equal to 1. Okay. So I'm directly showing you the values that I get for y. Okay. So the selected values of x are 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1, and corresponding y values are 0, 0.19, 0.35, 0.48, 0.59, 0.68, 0.76, 0.83, 0.90, 0.95 and finally 1. Okay, then that ends our step number 1, where we have generated xy data. Okay, in some cases they may give this data, so there is no need to follow step number 1 in that case. Now let us move on to step number 2, plotting of the distribution diagram. So how it is done? All x values, they are plotted on the x-axis, and all y values, they are plotted on the y-axis. Okay, so once you have the distribution diagram, next step is plotting of the operating line. I have shown the graph on the next slide. So how are you going to plot the operating line? For that, slope of the operating line can be used. Slope of the operating line for flash distillation is -1 minus f upon f, where small f is the fraction of the original feed that gets vaporized. So f is 0.6, that is given to us. So you can get slope as -1 minus 0.6 divided by 0.6, that is minus 0.4 divided by 0.6, that is slope is equal to minus 0.67. It is minus 0.67. Slope is minus 0.67. Okay, so we are going to use this slope for plotting the operating line. Okay, now let us move on. Okay, now let us learn how we can plot the distribution diagram first. So for that, you have this graph where on x-axis we are going to plot different values of x, and then on y-axis we are going to plot different values of y. Okay, now if you look at the scale, on x-axis 1 centimeter is equal to 0.1, and on y-axis also 1 centimeter is equal to 0.1. Okay, so we have a square plot, you can say. Okay, so now let us move on it. So now we have already VLE data available with us. You just have to plot it. So if you go on plotting those points, you'll be getting a curve like this. So this curve is the distribution curve. So you are going to get the distribution curve. Okay, and then for reference I am going to plot the diagonal line. This is the diagonal line, diagonal of a square, diagonal line. Okay, now xf is given to us. Let me just first erase it so that xf is given to us. Xf is 0.5. Operating line for flash distillation will start at xf. So you have xf as 0.5. So the operating line will start at 0.5. So I'm going to get a point where xf is equal to 0.5 or x is equal to 0.5. So I get this point. The y coordinate of this point is again 0.5, you can see. Okay, so coordinates of this point, they are xf, xf, the point where the operating line intersects the diagonal line. In my earlier video I have talked about it, you can please refer that. Okay, then now our objective is to plot the operating line which will be starting at this point and which is having a negative slope. Slope is minus 0.67. So operating line will be something like this. a line with a negative slope. Okay. Now in order to plot a line with a given slope on a plot where you have same scale on both the axes, so there is one technique that you can use. You can use the definition of tan theta in this case. So if this is a right angle triangle, let me just draw it. This is a right angle triangle. A right angle triangle, and if this is theta, and let us say that this side, length of this side is m, and length of this side is e. Okay, so as per definition of tan theta, in this case tan theta is m upon a. Now what I will do, I will make a is equal to 1, or if a is equal to 1, then tan theta is equal to m, the length of this side. Are you understanding it? Tan theta is nothing but slope of this line. Tan theta is nothing but slope of the line. Okay? So if a is equal to 1 as per this diagram, then tan theta, the slope of the line, will be equal to the length of the opposite side. Are you understanding it? So same concept I'm going to use while plotting this line. So I'll make this length. So I'll be drawing a right angle triangle where this side will be equal to 1 and this side will be equal to the slope that you have. Okay, so we have to plot a line of negative slope. That's why we are going on the left side of the point from where the line will be starting. If it was a line of positive slope, then in that case you'll have to travel in the right direction. Okay, but here slope is negative, so we will be traveling a distance of 1 on the left in horizontal direction, and then a distance equal to slope in the vertical direction. Okay, so first I'm traveling a distance is equal to 1. You can see. Okay, then in the vertical direction from this point I'll be traveling a distance that is equal to slope. Slope is 0.67. It is minus 0.67. That's why we are doing it on the left side of this point. So I get this point. So I have this point, I have this point. You simply join those 2 points and get the line of desired slope. Okay, so in this case the black line, which is the operating line, it has a slope of minus 0.67. Okay, now in order to get let me first erase all this. I hope you have understood the concept, how you can plot a line of given slope on a square plot like this. If you have any doubt, you please mention those doubts in the comment section. Okay, now let me first do it. Okay, so I get, now our objective is to know coordinates of this point. So this x coordinate of this point is, if you read it, it is almost 0.39. So in that case x will be 0.39, and the y coordinate is 0.58. So y will be 0.8, and that is what we are supposed to report. So x is equal to 0.39 is composition of the liquid, resulting liquid, and y is equal to 0.58 is the composition of the resulting vapor. Okay, so in this way you can solve this numericals like this by plotting the operating line. Now we will discuss how to get these values, x is equal to 0.39 and y is equal to 0.58, without plotting the graph. Now let us understand that. Okay, so let us understand how to get it analytically. Okay, so we are supposed to get x and y. X and y is the desired answer. So this x and y, if you have seen the graph carefully, these are the coordinates of the point of intersection of the distribution curve and the operating line. So x and y, they can also be obtained by solving equations of these two lines, by solving equation of distribution curve and then equation of operating line simultaneously. X and y can also be obtained by solving equations of the two lines simultaneously. Now what is the equation of the distribution curve? We have used this equation to get to plot that curve. So y is equal to alpha ab x divided by 1 plus alpha ab minus 1 into x. Alpha ab is known to us, it is 2.16. So that gives us y as 2.16 into x divided by 1 plus 2.16 minus 1 into x. Therefore y is equal to 2.16x divided by 1 plus 1.16x. Okay. Then you have equation of the operating line. Operating line equation is minus 1 minus f divided by f divided by minus 1 minus f divided by f into x plus xf divided by f. I have derived this equation in my previous video, you please watch it. Okay, f is known to us, it is 0.6, and xf is also known, it is 0.5. So if you use those values, you have y is equal to minus 1 minus 0.6 divided by 0.6 into x plus 0.5 divided by 0.6. Therefore y is equal to minus 0.67x plus 0.83. So this is the equation of the operating line. Okay, so we have the two equation of the distribution curve and then equation of the operating line. Equation of the distribution curve is y is equal to 2.16x divided by 1 plus 1.6 into x, and equation of the operating line is y is equal to minus 0.67x plus 0.83. We have got these two equations just now. Now what we will do, we will equate values of y. So this equation gives y, this also gives y, so we will equate the right hand sides of these two equations. So if I do that, I will be having 2.16 into x divided by 1 plus 1.6 into x, that is equal to minus 0.67x plus 0.83. I'll simplify it. So this is 2.16x is equal to minus 0.67x plus 0.83 into 1.16x. So now we can solve it. We will simplify it. So I have shown the simplification. So you have 2.16x is equal to minus 0.67x plus 0.83 plus 1 plus 1.16 into x. So that is 2.16x is equal to minus 0.67x into 1 plus minus 0.67x into 1.16x plus 0.83 into 1 plus 0.83 into 1.16x. I have multiplied these two brackets. That is 2.16x is equal to 0.67x minus 0.78x square plus 0.83 plus 0.96x. Again after simplifying it. So therefore after further simplification gives us 0.78x square is equal to minus 0.67x minus 2.16x plus 0.83 plus 0.96x. So what I have done, I have brought this minus 0.78x square on this side and I have taken 2.16x on this side. Okay, then we will simplify it on the right hand side of the equation. So it is 0.78x square is equal to 0.83 and minus 0.67x minus 2.16x plus 0.96x is minus 1.87x. So you get this equation. 0.78x square is equal to 0.83 minus 1.87x. So now I'll put it in the form of a quadratic equation. So 0.78x square plus 1.87x minus 0.83, that is equal to 0. Then I'll make coefficient of x square as 1. So for that I need to divide with 0.78. So if I do it, it will be x square plus 2.4. 2.4 is 1.87 divided by 0.78, and 0.83 divided by 0.78 is 1.06. So you get this quadratic equation: x square plus 2.4x minus 1.06 is equal to 0. So this is a quadratic equation, and you can get the roots by using this formula: x is equal to minus b plus minus under root of b square minus 4ac upon 2a. Let us get those roots. So we have the quadratic equation. Once again, I have written it over here: x square plus 2.4x minus 1.06 is equal to 0. This is a quadratic equation. The roots are given by this equation: x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. For this quadratic equation, a is equal to 1, b is equal to 2.4, and c is minus 1.06. So if you put those values in this equation, you get x is equal to minus 2.4 plus minus under root of 2.4 square minus 4 into 1 into minus 1.06 divided by 2 into 1. So if you simplify it, you'll get x is equal to minus 2.4, and if you solve the equation under square root, you'll be getting it as 10. So you have minus 2.4 plus minus under root of 10 divided by 2. That is, x is minus 2.4 plus minus 3.616 divided by 2. That is, x is minus 2.54 plus 3.16 divided by 2, and x is minus 2.4 minus 3.16 divided by 2. Okay? So that means you have x is minus 2.4 plus 3.16 divided by 2, one value for x, and the other values: x is equal to minus 2.4 minus 3.16 divided by 2. So this gives us x as 0.38, and this gives us x as minus 2.78. So mole fraction, negative mole fraction is absurd, so that can be neglected. As mole fraction cannot be a negative value, we are going to ignore this, and that will be the true value: x is equal to 0.38, and by graphically we had obtained it as 0.39. Okay, then you can get y from any of the two equations. So for example, you have this equation for y. Y is equal to minus 0.67x plus 0.83. If you put x is equal to 0.38 in this, you are going to get y is equal to minus 0.67 into 0.38 plus 0.83, which gives us y as 0.58, and graphically also we have got the same value. Okay, so in this way, without plotting the graph, we have got values for x and y. Okay, so that ends my discussion on the numerical. We have got the solution. I have told you how you can solve it by using a graph, or by plotting the distribution diagram, or how you can get it without plotting any graph. Okay, so I hope you have understood the concept. You have understood how you can solve numericals like this. So with this, I end my discussion for today's video. Thank you for watching my video. Thank you for being with me. Please subscribe to my channel. Tell your friends to subscribe to my channel. If you really like my videos, you please hit the like button. Also hit the bell icon so that you will be notified as soon as I upload any new video. Thanks for watching. Do subscribe to my channel. Have a nice day. Bye bye.